Hello, friends. Today we're going to learn more Python. We're going to learn about the basic syntax, and this is video 2. Let's open a new file by pressing the new file button, and let's talk about basic. Let's call it basic syntax. Py. Now, let's review some stuff. We know how to concatenate strings, and we know the data types. So let's go more in depth with the data types with the operations. Now, integers can hold up to 300 digits. They hold up to 300 zeros. You can, if you want to simplify something, you could just do. And you could add up big numbers like this. Now let's run a debug. And they give us an approximate answer. Let's do this. 1.2e times 3 plus 301. Yes, this is true. Oops. Now we have stuff over here, okay? Now let's talk about the basic operators. In math class, you probably know some of these operators. X plus y, x minus y, x plus y, x minus y, x times y, x divided by y. These are the operators. These are the basic operators, okay? So we could do stuff. We could do print 3 plus 4. We could do print. We actually let's store these values into variables and store stuff. Again, we'll talk about variables later, but let's do some operations. X plus y, x minus y, x times y, x divided by y. These are the most basic. And then we can also do some more stuff like there's an operator which finds just the quotient. When you divide x by y, you know there's a quotient remainder. Okay, it gives you just the quotient. And there's another one which gives you just the remainder. Yeah, these are not common. The percent sign does not give you percentage, it gives you the remainder when you divide these two values. And double slash gives you the value when you divide x and y, it gives you the quotient. Let's look at these values, okay? 7. 3 minus 4 is negative 1, yes. 3 times 4 is 12, yes. 3 divided by 4 is 0.75, yes. 3 divided by 4, yes, is 0. There's a remainder of 0. And we also have 3 divided by 4 leaves a remainder of 3. Let's switch these up. Let's call these 5 and 4. These are much better examples. Okay, so now we have a new set of numbers. 9, 1. The difference is 1. 5 times 4 is 20. It's 1.5. Because 5 divided by 4 is 1.5. 1.25. 5 divided by 4 is a quotient of 1. It has a remainder of 1. Let's do 7. Now it's the same thing. Okay, now it's not the same thing. You have different values. But these all match what I just said. So now we can basically delete all this. And now let's focus on something else. What are variables anyway? What was I showing you just now? What were those things? They're something to help you store stuff. X you could call them anything, except you could not start with them with a number or symbol. Like you were to do binom 3. Actually, I think you could start with a symbol. I don't think you could start with a number. I don't think this will work though. But I suggest do not start it with a symbol. Yeah, it actually works, but do not. You can't start it with a number. You must have proper symbols. You can't have like weird symbols like high. High times 2 is not a variable name. High ampersand 2 is not a variable name. Need a proper variable name. You can use underscores. Yeah, practically you can use underscores as the only symbol, and you can use numbers and you can use letters. But for now, let's just focus on basics. Like we could call num. Okay, num is a proper variable name. Num stores 3, and we can print out the variable name either. Let's print a formatted string, okay? Let's print the number. So we have the number is. The number is. And now let's print out num by using our brackets syntax. And now we can put any other data type in here. So we have num is an integer data type, so it's storing an integer. If it stores a float, you could also use it. So let's do it. Or again, we can just use the easier method, which I want to start using more than this f strings. So f strings will come in useful later, but for now, I'm not going to use it that much. It's more easier just to use concatenation. So let's just stop this. Now it stores stuff. We can do operations with stuff as well, as I showed you. And now let's move on to inputting. What is input? Input is what comes in. Remember, in and out. Remember, in and out. In, we just ask the computer something, but now let's see we are asking the user for something, and what comes out is what we're asking them. Okay. So remember, in out. So now we have to store this value. Input. There's an input function to ask the user to give us input, and then we say input input a number. But wait, we're not done, as this is considered a string. And we want to use operations on this, so we have to use int. Because if you use it as string, the compiler or the person or the thing which reads your messages will think it's a string, which is like a letter. But it's not a letter, it's a number. So use int or float, whatever you want as numbers. If you want to input a whole number, if you want to do an integer, so let's just clear up the confusion. And now we are asking them to input. What is this part anyway? This is the prompt in computer science language. It asks us, it tells the user to do something, to actually do something, not just run the program out itself, doing things itself. It's getting the user involved, which is how many programs work today. See, open up the Google screen. You have to already input something. This is the prompt. Search Google or type a URL. And now we're inputting something. Let's say this thing which I was working on earlier. See, now it shows us stuff, and then we also have to scroll. The user have to do things, and then if the user scrolls, events happen. These are all events. These are all mouse events. The user has to contribute in the program working. If you press this, it'll go here. See? If you press this, it'll go here. Things change. It doesn't run by itself. So let's start to get the user involved with the input statement. It inputs a whole number. And then we print. Now when the compiler does something, printing the number you inputted was. Now let's do X. No more F strings anymore for now. Oh yeah, I forgot. We have to keep some space because it looks neater. Why can't I just clean out this debug console? Yeah, here. That's how you clean out the debug console. You can press this button, it cleans out everything. Input a whole number. Okay, let's input a whole number. See? They ask the user for something. And this is the most basic programs. You just input the whole number. If you want to do operations with print, here are some operations. So operations listed below. Also, this is a good opportunity to tell you something cool. There are some escape characters. Like not everything is interpreted as a string. This is an escape character. Create a new line. A new line. To do a new line, you use \n. This creates a new line for you, and then you can format. This is used for formatting. And then you also use Command T to create a new line, a new tab. If you want to use these both, you can create a new line and a new tab. And then there are many other like backspace character and lost carriage returns, which you can see later. So basically, here's some operations listed below. Then we can show addition. Oh yeah, we have to get two numbers first. So let's store a different variable. And let's remove this since we don't need it. Here are some operations listed below. Addition. And then it shows the addition x plus y. Remember school of math. This then we have subtraction. Now I want to do a new line, obviously. Subtraction. Multiplication. Division. And division. Division. Remember, you have to add the quotes, or you could use f strings. Wait, what does it say over here? This was not closed. Over here, see, we have a weird stuff. Look at all this. All this stuff is weird. All this weird stuff. So let's do invalid syntax. Perhaps you forgot a comma. Addition. And see, now it's fixed. Let's clear out our terminal. Okay. Input a whole number. Input a whole number. Now, what do you want to input? 3, 4. Some operations listed below. See, these are all the results. This is also a basic program. Now, let's focus on more stuff. Let's focus on conditions, while loops, and for loops. This is a lot to take in, but this is quite some cool stuff. Remember from last class that we saw this, we didn't have to understand it, but let's understand things now. Oh yeah, why did I remove that? You know what, I'm gonna keep that. I'm gonna keep this input statement at least. Not this print statement, I don't need it anymore. But let's do some conditions, okay? If x, okay, x is a number, x is greater than y. What this means is that if if x is greater than y, like if you have 5 over here, if you have 5 and say you have 4, of course they will go into this if statement because 5 is greater than 4 and x is greater than y. Then it goes in here and then some stuff happens. Now basically you have to put a semicolon to start the block, and then you do some code over here like print x is bigger than, okay, and then else you could do you could do this is smaller. Else nothing else if smaller. Else. Well then, if it's not greater than y, wait, actually, it's okay. It doesn't have to be else because remember we have to check if x equals to y. Now why do we put two equals? Why can't we put one equal? Because it doesn't work like this. This already has statements. Remember when we assign variables to values, you use an equal sign. You have to use double equals. It which is weird. But many other coding languages also use this. Like most coding languages have to use two equals. So it's not as humanly as you think, but it's still like it. Two equals. Then x is equal to elif. What is elif though? What does elif mean? It's just a shorthand form for else if. Like else if we have another situation. If x is equal to y, you have to think of all the situations and then else. Like if none of these situations match, we can also do L if x is smaller than y, but this saves time since we already know we checked all the other possible solutions. We can just do x. We can save code, which we don't need. X is smaller. In this case, the x has to be smaller. Okay, let's input another whole number. And now let's show some while loops. Okay, this is if else elif. This is conditional programming. Conditions means are different conditions. If you have this is one condition, we check each different condition. We have different output. If we put different numbers, we'll have different output. Now what if we want to keep repeating this? What if we don't want to just stop? Well, first we have to move everything inward, and then I'll show you why later. One thing I don't like about Python, you have to indent. And for loops, you'll have to indent. So why do we have all this stuff? Because we're putting a while true loop, which will run forever. But we'll put a statement which will check if it breaks. If we put it invalid, and now we check over here, code is not unreachable, unintended, not expected. Basically, we have while true. No, this is a while true. This will go forever, so it might ruin you. So what if you want to start something? Well, let's go a bit deep. Okay, so what if we want to ask them to put a specific value, which is not actually like proper? Like if you don't put a proper value, of course it'll end. But what if you want this thing to stop at some point? If you want to stop equals to input do you want to continue? Input 1 to continue. This basically says if you want to continue this program on and on. Now there's also a method. We could just ask them how many times. But let's just do this previous method. Input 1 to continue. And then since this is a string, we're actually just going to say if input if stop does not equal to 1. We have to do string 1 since this is a string. We break. What does break do? Break means that it stops the while loop. It stops the while loop, yes. Input a whole number. Oh, wait, there's one problem. Why do you not see that? Now think about it, we're the else statement, so of course they won't see it. It has to be smaller, so we cannot go on forever. 4, 3, yes. Sure, I'm gonna leave some space. So let's see, 4, 3, 1, 5, 6, 1, 7, 7. And then it stops. It breaks the loop. It just breaks it. While means it keeps on continuing. Sometimes you can also put Boolean statements like other statements. Instead of true, you could put like while counter does not equal to 1. But you have to keep continuing it. It keeps repeating until it reaches some condition. Like say you want to print all the numbers. Say you want to print out all the numbers. So let's say let's call it counter, okay? Counter equals 0 while counter less than 100, which means that until the statement is met, it'll keep on continuing until the statement is met. You print counter. Sorry, not the string. I meant like the variable. Oh yes. We have to forget. Counter plus equals to 1. This will keep on going forever. And this is less than, so I'll only print till 99. When it reaches 100, I'll just immediately stop. We could also skip some numbers. Say this is a weird thing, but say we want to skip a number 50. This is an example to show you some other functionality. Counter equals to 50. We don't want to break the loop, but let's continue. Let's ignore this, but let's just continue the loop. Now we can do the same thing. Oh, wait, what's the error now? Okay, if counter equals to 50, continue. Oh yeah, because you have to do continue after. So let's run this again. See, now it's the same thing, but you don't see the number 50, do you? Oh yeah, because it prints as well. What am I thinking? It continues, but you print it. You have to print it. Now we have all the numbers. Now it goes from 100, since like I put print after. But you won't see the number 50. Yes, 4951. But if we just comment this, but you just put like a hashtag next to it, so it doesn't matter anymore. And you will see 50 right over here. So yes, this matters. Now, let's stop this, and now let's do an easier way of counting. We'll introduce the for loop, which is meant straight for counting and iterating. What is iteration? You'll see, but let's first introduce it. Now we have to use some functions, and functions are things which does tasks. We've been using functions. But okay, for counter, we can already define the counter on this for loop. In range 100. Now what does this mean? Let's now, okay, counter, it creates a variable. The cool thing about the for loop is that you can create a variable and then in range 1 to 100. Now why I only have to put 100 because it's already default set to 1 at the beginning. But if you were to have all the values inside of here, 1 to 100, and you skip count by 1, but you don't need these two ones since it's default. But yeah, this is our counter in range 1 to 100, so it just iterates. What does iterate? It goes to all the values. It goes to all the values in this possible thing. It loops through all these values, and then you just print counter, and you can also use save, continue, and break. Again, what am I doing? Usually they use for x though, so I think we already use x, so let's just use for n. 1 1 0. Again, this is the upper bound, so it only goes to 99. So if you want to do it, you have to have 101. So that's the cool part and the weird part, which is sad. But it's the same thing. It does the same functionality as I showed you. Now what does it mean to iterate? Well, range 100 is basically all the values in this range 1 to 100. It's basically, and we skip counting by ones. It jumps over by 1. If we were to jump over by 2, we only get all the even numbers. What? So this basically means we get what? We get all the odd numbers. Right? It jumps counts by 2 until you reach 100 because 101 is the upper bound plus 1. So now we'll get all the odd numbers. And now we can also get all the even numbers. Like this. Now there's more stuff we could do with for loops. This is something advanced, but this is a list of items. So we have a list of items, okay? Actually, no, we could do something else, okay? Say we have a string, okay, called fruit, apples. We could do for and in range apples. We could go through other apples. No, we could also just iterate straight over here. And we'll print all the letters A, P, P, L, S. So for added apples, we just print all the letters in apples. This is how it's going to work. And now we can also iterate over values in a list. Now, my list, this is advanced. We'll talk about more functionality and operators, but you could create a list like this. It's a list of, we could call this list fruit actually, but let's just, you might be wondering why I'm using single quotes, because single quotes work with strings as well, which I should have told you earlier, but I just realized. So you could also use single quotes in strings, which is what they usually use in lists. So apples, banana, orange, grape. What? And now we can use this. Let's call this fruit. Call it more meaningful. And now we can do for edit fruit, and it prints all the values like it's apples, bananas. It prints all the values: apple, bananas, orange, grape. Now that's it for this video. In the next video, we'll learn about functions. Continue watching Python course. See you later.